Good. So I already have written the difference quotient. I already know that this is already the function. It's given. This I cannot do anything to. The only one that I have to slightly work on will be this. So I will continue here. So that's minus this function divided by h. And can anyone give us f of x plus h for this function? How will I write it?
It would be 1 over x plus h minus 7 squared.
Great job. Who was that?
Natalie.
Thank you very much. Do we all understand this? Do we all understand how Natalie obtained this?
Yep.
Yeah.
Okay, perfect. Moving on then. What is the next step? Remember, there are 1 and 2 and 3 that have to happen. Whenever we determine the difference quotient, h from the numerator has to go away. H from the denominator has to simplify. And h still has to be in the final answer. So remember these 3 items. Okay, so what is the next step? What will we have to determine now?
We need to find the greatest common denominator for the two terms in the numerator.
The least common denominator. And as I mentioned, always watch me run out of room. I always do. Sorry about that. You'll get used to it. What is the least common denominator?
X plus h minus 7 squared times x minus 7 squared.
Very good. Awesome. They have nothing in common. This is by itself, nothing in common. This is by itself, nothing in common. So now, when I multiplied this quantity by this in the denominator, I have to do the same thing to the top. So up here at the top, I have x minus 7 squared, meaning I have to multiply 1 by x minus 7 squared. Now, x minus 7 squared was multiplied by x plus h minus 7 squared, which means this is a reminder to myself, don't forget to multiply the top by the same quantity, otherwise you change the fraction, the value of the fraction. Okay, perfect. Now, 1 times this. Can anyone give us those terms quickly? This is a different story. We're going to take it aside. But can anyone give us this? This is what we did on the first day of classes. Can anyone tell us?
X squared minus 14x plus 49.
Excellent. Is that clear? Who was that, Brianna?
Yes.
Perfect. Okay, so now minus. Now, this is not a binomial. So let's take it on the side. So I have x plus h minus 7 multiplied by x plus h minus 7. I don't have a formula for this. Okay, so here we have to follow h distributed to these 3 terms, h distributed to these 3 terms, negative 7 distributed to these 3 terms. Initially, we have to have 9 terms. We'll see if they simplify a little bit. If not, 9 terms then. X times x. Yes, x times h. Very good. X times negative 7, which is negative 7x. So this is done. Now we continue with h distributed to these 3. So plus xh plus h squared minus 7h. So now this is done. So we have 3 plus 3. I need 3 more. Negative 7 now distributed to these 3. Minus 7x minus 7h and plus 49. I hope I can clean this up a little bit. So let's see what we can do here. So we have x squared is by itself. Now I see 2 of these, so plus 2xh. I see 2 of these, so minus 14x. I see 2 of these, so minus 14h. I see a plus h squared and a plus 49. Making sure that everything is accounted for. So now it collapsed from 9 terms to 6. This is what I have to put up here. But remember, there is a minus in front, which will change every sign to the opposite sign. Okay, I'm going to put it in different colors so you see it. Minus x squared minus 2xh plus 14x plus 14h minus, I may be able to make it this time, and minus 49. Can you believe it? The 1, 2, 3. Number 1, all terms without h, maybe even more, but at least the terms without h must go away. And they are. So 1 is okay. Now this is number 2 has to disappear. So I put a triangle so you know where I continue. The top has 1, 2, 3 terms. What do they have in common?
They all have an H.
Very good. Let's see what is left in parentheses.
2x, a negative 2x plus 14 minus h.
Excellent. I have to copy the denominator. X plus h minus 7 squared, x minus 7 squared. And this h is h over 1. How do I divide two fractions?
Multiply by the reciprocal.
Thank you very much. Who was that? Nick?
Nick.
Thank you. Good.
Bless you.
Very good. So now number 2 has to happen. And here it is. And it did happen. And number 3 is obvious. The final answer has still an h in it or more, but it has to have at least one. Negative 2x plus 14 minus h over x plus h minus 7 squared, x minus 7 squared. Okay, anything else or we move on? I'd like to go back.
Thank you.
Thank you. Good pick.
I actually had trouble with the, I want to say it's called the piecewise.
Defined function. Did you watch the video from last time?
No, but I went over the stuff in the textbook on it. But I
They
still-
show a different method. I don't recommend it, but I accept it.
Okay.
So I didn't say that. I didn't say it, but I'm going to say it now. I don't want anyone to reinvent the wheel. In other words, if your method works, I'm fine with it. Okay? So if you don't have any method, please try to understand mine. But if you do have a method, I'm fine. Now, I highly recommend rewatch the video. If you have a piecewise defined function, I would rather show it now. So I'm more than happy if you have one, please give me one.
I don't, but I'll rewatch the video.
But is there a particular problem that you wanted?
I was just having trouble with the one for the homework. It was.
That's fine. The homework is, no one can upload anything, so I can work on the problem before I put the solutions up. So just tell me, is it a problem that I picked from the book?
Yeah.
Okay, do you remember which number? Because I didn't write solutions yet.
Let me check which number.
Number 58.
Number is 58?
68.
68, very good. Let me copy it. I see it, 68 on page 23. Let's go over it. In the hope that this will satisfy everyone and we don't have to go over this again. But if we do, we do. We will. Okay, so remember every time I'm asked to graph a function, I have to go through these steps. no matter what they say, no matter what they do, I don't care. If I am asked to graph, I have to go through domain, table of ordered pairs, and graph, number 3, and number 4 range. Full credit is
Professor,
given.
your camera's still on you, not on your notes.
Thank you. I'm sorry. I get carried away. Sorry about that. So this was the function, and we have to go through these 4 steps. If we're asked to graph, we have to go through these 4 steps. Domain, first, table of ordered pairs. We wrote that last time. The graph, and then the range, in this particular order. So can anyone give us a domain of this function? And then we will change each piece into an interval notation. This one cannot be written as an interval. It's a point.
The domain would be negative infinity to 0.
So what?
Negative infinity to positive infinity.
Right, there is nothing missing. This interval says negative infinity to 0. 0 is here, some value. When x is 0, there is a value for y. And this is 0 to infinity. So nothing is missing. So the domain, so the number 1 is everything. Do we understand how we got the domain? Everyone?
Yes.
Okay. So now the table of ordered pairs. This will not always be the case. Obviously, I have to have 0. This point is very important. 0, comma, negative 3. And you see this parenthesis under 0 to the left, and this parenthesis under 0 to the right. Now, on the table of values, of ordered pairs, I should say, I will put that to the left of 0. I have to use this function. At 0, the y value is negative 3. And to the right-hand side of 0, I have to use this function. Is everyone okay so far? Okay. So now this is quadratic, remember? So x squared, the graph of x squared, is something like this. So this is y equals x squared. So on the left-hand side of 0, I have 0 inside of the parenthesis. To the left of 0, I will plug in negative 1. Negative 1 squared is 1. You can continue, but obviously it's going to be just this portion of the graph because it's between negative infinity and 0 only. This is for the entire graph, but that's not what we're graphing. When I plug in 0 here, I get 3. When I plug in 1, I get 1. Let's also plug in 2, because 2 times negative 2 is negative 4, plus 3 will be negative 1. So obviously at 1.5, or 3/2, right here, there is a 0. I should have left a little bit more room in there. Okay, so now I'm ready. I will use 3 colors so you understand that they cannot overlap. Here it is. That's why I'm kindly asking you to watch the videos. You're going to be very happy when you do. You're going to be way ahead. Okay, so at negative 1 is 1. It's a full point, of course, but 0, 0 is not a full point. It's an open point, and this is the graph because it's quadratic. I'm done with orange. I reach 0, comma, negative 3 with blue. They're not connected, and this is a full point. And this is the middle with blue. Now purple. 0, 3 is this point, which is also an open point. 1, 1 is right here. 2, -1 is right here, and with the cross of the x-intercept or the cross of the x-axis at 3 divided by 2. So here it is. Oops, I missed it. This is the graph of the function. 3 different colors, orange on the left, only 1 point here in blue, and purple on the right. As I mentioned before, if you graph something like this, extending where it shouldn't be extended, I can't give credit. So notice by the vertical line test, this is a function. If you were to graph something like this would not be a function by the vertical line test. And now step number 4, so this was step number 3, and step number 4 is the range. I cut the function with horizontal lines, and the horizontal lines will always hit the function. So then the range must be also -∞ to infinity.